Okay, so this is part 2 of measures of spread. Last part we looked at measures of spread as they related to the mean. These are measures of spread related to the median. I will tell you that this is a lot less calculation heavy. Okay, so keep that idea in mind. And you do have to know again how to use the median in order to be able to do this measure of spread, just like for standard deviation and variance, you needed to know the mean before you could do that measure of spread. Okay, because it all sort of surrounds the measure of central tendency, the median, and the mean. So the median, if you go back to the median, just a few things about the median, remember, it's the middle value. So if you count the number of values, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, okay? That's going to be 11 values. You can use the formula for the median. We call it Q2, and you'll find out why in a second. But the formula for a median is 1/2 times n plus 1. If the result is right on a number, okay, then that's the median. If the result is a little bit above a number, then you have to sort of go between that number, rounded down to 0, and that number rounded up to the next number. Okay, so this example here is a good example of that. There's 11 values, that's your n. So 1/2, 11 plus 1, oops, sorry, my mistake. 1/2, 12, which is 1/2, 12 is 6. Okay, so that means on the 6th datum is where we find our median. Okay, so we go 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, doesn't make a difference. So this is a situation where the median is directly on a specific value. If I say put in 12, and I had, I don't know, like the number 13 over here, then we'd have 12 data values. My median, my calculation would be 12 plus 1 or 13, and that'd be 6.5. 6.5 says it's between the 6th and the 7th. Okay, so you would go and count to the 6th, 1, 2, 3, 4, 5, 6, and then you would count to the 7th, I guess it would be that one, or you could count to the 6th from this direction, 1, 2, 3, 4, 5, 6, we have to include the 13, and so it would be between the 4 and the 7, in which case the halfway point would be 4 plus 7 divided by 2, 5.5, and that would be your median, if, of course, the 13 was there. It's not in this case, so my median is quite simply a 4. Okay, in that particular data set. Okay, so since there's 11 values, the median is the 6th datum having a value of 4. This divides the data set into 5 below and 5 above. Okay, so if you look, the median kind of divides it into 2 pieces, a piece with 5 below and 5 above. What we're going to do in order to be able to look at the measure of spread, the standard measure of spread that we use, is we're going to look at what are called quartiles. We're going to take the data set, and rather than dividing it in half with the median, we're going to divide it into halves of halves, okay, or in other words, quartiles or quarters, okay? So again, 5 below, 5 above the median. The median is the first half of the data set of the first quartile, so 1, 2, 3, 4, 4, not including, of course, the median, all right? And the middle of this grouping of the first 5 is 1, 2, 3, 4, 5, so it's found on the 2, okay? For the second half, okay, sort of for the quartile that's above here. So this is going to be an important value. We call that the first quartile, or Q1. That's Q1. That's Q2. Q2 is the second quartile, 2 quarters, which is a half, which is the median, okay? And here's Q2 again, because this is the second half of the data set. That's this over here. Okay, then we've got 1, 2, 3, 4, 5 data values. So in those 5 data values, the middle of those top 5 is going to be the 11. So that would be our Q3. Okay, now there's other ways to find Q1. Q1, if you remember, Q2 is this. 1/2, because it's 1/2 of the data set, n plus 1. Q1 would be 1/4 of the data set, n plus 1, because it's the first quarter, and Q3 would be 3/4 of n plus 1. Okay, so there's really easy ways to calculate these, especially if you have, I don't know, like 55 or 1,000 data values. It's a pain in the butt. And you can get Microsoft Excel to do this in the computer, and I'll show you how to do that later on. But right now, if you have to do it by hand, if you have a data set and there was, I don't know, 38 values, you would go 38 plus 1 is 39, divide it by 4, and again, it's the same strategy. If it's exactly on a value, okay, like in this case, we did the 11 plus 1, which was 12 times 1/2, which was 6. So if it's on the 6th value, it's exactly, the quartile is exactly on that value. For example, if we took these 5, right, you would go, if you took these 11, you would go 11 plus 1, which is 12, times 1/4, which is 3, exactly on the 3, which is the 3rd value, which is where Q1 is. For this one, again, it'd be 11 plus 1, 12, 12 times 3/4. So 12 times 3 is 36, divided by 4 is 9, and that would be the 9th data value. 1, 2, 3, 4, 5, 6, 7, 8, 9. The 11 is the 9th data value. So you can use these formulae as well, okay, to help you figure out quartiles, and even better for percentiles. Okay, so that being the case, then that's how we find those things. Now, why is it important to find Q1 and Q3? Well, the measure of spread, standard measure of spread we tend to use is an interquartile range, which is quite easily the Q3 value minus the Q1 value. It's not crazy. It's not some square-rooted summation formula. It's nothing having to do with that. The median is all about positioning, and so Q1 and Q3 is all about positioning and the value at that position, so we subtract the value. So it's like a range from like the bottom 1/4 to the top 1/4. So what it does is it takes the quarter mark and 3/4 mark, and it leaves the half of the data in between. Okay, so if I map this out for you, here's Q3. So first quartile, third quartile. Q2 is the second quartile. This, which is the interquartile range, I'll call it IQR because I usually abbreviate it that way. Interquartile range is actually the range for the middle 50% of the data. So that's what the interquartile range is. Very easy to do. When you compare it to the standard deviation for grouped or for raw, this is a piece of cake. And it is, really, it is. So let's go through and we'll alter the data set so we can do some more work with it. Okay, so here's the data set here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've added another value. That makes the mean and the standard mean in Q1 and Q3 a little bit more difficult to calculate, but nothing too crazy. But it's just another example for you. You can treat it as a totally different data set if you want to. So my n is equal to 12. Okay, now if you want to just do this by counting, because you only have 12 data values, it's very easy, but you could also do it by the formulas. Q1 is going to be 1/4. 12 plus 1, which is 1/4 of 13, which is 3.25? 3.25. 13 divided by, yes, 3.25, okay? Q2 is going to be 1/2 times, well, it's going to be 12 plus 1, so I'll just jump a step, 13. Okay, and that's going to be at 6.5. And then Q3 is going to be 3/4 of 13, again 12 plus 1, 13, which is 39 divided by 4, which I think is 0.75. Yes, let me just make sure to be right. 9.75. Okay, now what does this tell you? Okay, well the fact is none of these are on specific values, so none of these should be on specific values. Okay, so that means that this is going to be between the 3rd and the 4th. This is going to be between the 6th and the 7th. And this is going to be between the 9th and the 10th. Okay? Now, if we go ahead and count it, because we only have a data set of 12, it's very easy for us just to count them. Okay? So there's 12 data values. Then halfway should be 6 from this side and 6 from this side. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So it's between these two values. So my Q2 is going to be halfway between those two. Okay, or the 6.5 between the 6th and the 7th, just like we calculated over here. Between the 4 and the 7 is 5.5, halfway between. Okay, now what that does is it leaves this 4 and all of these open, okay, for our Q1. Okay, because it's not directly on a value, we don't lose the median like we did up here. So it's a 4, 4, 3, 2, 1, 1. So there's 6 values below. 6 values below, cut in half, is going to be between 1, 2, 3, 1, 2, 3. So it's going to be right here, which is Q1, which is exactly what we thought, right? Q1 would be 2.5. It's exactly what we thought because Q1 is between the third and the fourth, the third and the fourth. Okay, and then here, same idea. 1, 2, 3, 4, 5, 6. 1, 2, 3 this way. 1, 2, 3 this way. And so it's going to be halfway between the 11 and the 12, which is 11.5. Halfway between 11 and 12. Or halfway between the 9th and 10th value. The 9th and 10th value. Remember, 9th and 10th and 1st and 2nd, they're all orders in the sequence. And they have to be from lowest to highest. The same way that we did with the median. So I guess I didn't restate that idea. And so here are our values. There's our Q1, there's our Q2, there's our Q3. Oh, it's 5.5. Okay, so our interquartile range is very easy. Take your 11.5 and you take your 2.5 and you subtract them. So my interquartile range is 9. Very easy. We also have another calculation called the semi-quartile range, okay, which is just the interquartile range divided by 2. That's all it is. It's not even difficult. Okay, so you take your 9 over 2 divided by 2, you get 4.5. Okay. Now we also have a diagram that shows us our measure of spread, and that's kind of the part that's a little bit difficult for this situation. It also does establish the situation that relates to an outlier. Okay, we didn't talk about an outlier for the first half of measures of spread, but measures of spread are really what determine your outliers, not just your median or your mean. Okay, what is an unusual data value? We'll get to the way in which we could use the mean and the standard deviation in order to figure out what an outlier is, but it does have to do with the z-scores. So we'll come back to that. All right. For now, let's just focus on, again, measures of spread related to the median. Okay, so what we're going to do is do a box and whisker plot. Now, this isn't a box and whisker plot that Excel does. This is a modified box and whisker plot. And I'm actually going to do the box and whisker plot with you guys here. It's not crazy. It's actually a number line, okay, but it's very easy to do, okay? So I just outlined the steps that you do. So the first thing you have to do is you have to figure out Q1, Q2, Q3. Have to do that, okay? So I'm going to create a number line, which is what we do for the plot, but then we have to figure out Q1 and Q2 and Q3, which we did, okay? This is the data set that we're using, the one that was at the bottom of the page. The Q1 is 2.5 and 5.5 and 11.5. And I've made this one so that there is an outlier in there. You could probably even figure out what the outlier is, but you draw yourself a number line. I know I've done a really ugly job of it, but there it is. You want to use a ruler, you can use a ruler. Remember, this is a bit of a sketch, okay, so I apologize for not being too neat. Then you, of course, figure out an appropriate scale. Now, we have to have a scale that has all these data values in it, 1 to 40. Okay, so I think I counted this in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So I think that there's 40. So if I start here at 0, and I go all the way to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. No, I should have had this set up ahead of time, but oh well. 1, 2, 3, 4, 20. 1, 2, 3, 4, 5, 6, 7, 30. 40. Hopefully I counted right. If not, you got me. Okay. But either way, you put a nice scale on there, whatever it is, make sure that it's done proportionally and make sure it envelops the entire data set. Because even if something's an outlier, we still have to plot it. Okay? All right, so then what we do is we start with something simple, okay? So first of all, we outline basically where Q1, Q2, and Q3 are. So Q1 is at 2.5, so there's 2.5, so that's where Q1 is. And you put sort of like the edge of a box, okay? Q2 is 5.5, so 1, 2, 3, 4, 5, and halfway, 5.5. We can even label that Q1. Q1, Q2 wouldn't be a bad idea anyway. And then finally Q3, which is 11.5. So 10, 11.5, there we go. And what this says, of course, here in step number 2 is draw a box with Q3 at one end and Q2 at the other. So by drawing all these lines for all my different values that I've figured out for, and I'll maybe outline it a little bit more so you guys can see the box a bit better. Okay, so there's my box. Okay, that's the box part of the box and whisker plot. So check, got a box. Okay, now it says place Q2 as a vertical line bisecting the box, the appropriate location between the number line. Don't cut it right in half. put it where it is, plot it where it is. In this case, it's a 5.5. In this case, I plot a Q1, Q2, Q3, which you can do. It doesn't make a difference. Okay, in what order you do it in. And then what you do is you have to do the whiskers. The whiskers are these sort of extra data values that show the spread of the data. Okay, now when you do a box and whisker plot, the whiskers go directly right to the end. Okay, so my whisker will go all the way to 40, which is my last value, and all the way down to 1, which is just right over here. So it's a short whisker on this side and a long whisker on this side. In a modified box and whisker plot, which is the one that we're doing, it outlines something having to do with an outlier. What is an outlier? And so we've determined that an outlier is 1.5 the width of a box. So the width of the box from here to here is my interquartile range, from Q3 to Q1. If you take one more box and another half, and one more box down here and another half, okay, that would be the width of the acceptable values. Those are the values that are not outliers. They're cool, they're normal, expected, whatever you want to call it. Okay, so what we do is we create an acceptable data range, and the acceptable data range has to do with literally how far the values are. So I have to calculate this. I take my Q3 value, which is 11.5, and I add 1.5 times my interquartile range. If you remember, my interquartile range was from 11.5 to 2.59, so 1.5 times 9, which is 11.5 plus 1.5 times 9 is 4.5. 13.5. And then calculate that number, of course. 11.5 plus 13.5, and you get 25. Okay, that means that any value within 25 or less is cool. Okay, it's acceptable. Anything above 25, unacceptable. Okay, so this creates an acceptable range. All right, I also have to do a range for Q1 below. So in other words, I have to do a range for both sides of what's acceptable. So Q1 is 2.5. And I subtract 1.5 times my interquartile range. Now this is the same number as this 13.5, so I'm just going to skip a step for the purposes of space, but 1.5 times 9, 13.5, 1.5 times 9, 13.5, okay? And then we go 2.5 minus 13.5, which of course creates a value of negative 11. So that's another side of my range. So any data values between negative 11 and 25 are acceptable. Any ones below negative 11 and above 25, unacceptable. Okay, that's my acceptable range. Now, I don't plot this on here, but if you want to, you can sort of put a dotted line or something, I don't know, like that. And the dotted line we're not going to put down here because this only goes to 0. And we don't have any values below 0. But if we had them, then we would put it down here. But we don't need to because it's just the acceptable range. It doesn't mean that I have to plot those values at all. And that's not where the whiskers go. The whiskers don't go at your acceptable range. Your whiskers go from your highest to lowest acceptable values. Okay? So 1 is definitely higher than negative 11. So 1 is acceptable. That's cool. Okay, it's my lowest value and it's also acceptable. If I had a negative 12, I wouldn't put my whisker there. That's where I put my whisker, my first lowest acceptable value. So I put a little whisker right there. I'll get to that in a second to show you what the whiskers look like at 1. Then I look up at the top and I say to myself, okay, is 40 acceptable? No, 40 is over here. It's outside of the 25. It's outside of the acceptable range. So 40 is not acceptable. We don't throw it away, but it is considered an outlier. We look at the next one inwards. If the next one inwards is not acceptable, then you also don't include that in the whiskers. But of course, it's a 12. Is 12 acceptable? Yeah, it's way less than 25. So 12 is acceptable. So that's the other edge of my whiskers, okay, at 1 and 12. And so my whiskers just kind of a bit of an ugly whiskers. They're kind of close there. But the middle 50% of the data is almost the entire set of the data. So it just shows you that really the data is not very spread out. But we still have this 40. And so what we do is I'm just going to draw a huge dot here at 40 to show you that we still account for the outlier. It still exists. There it is. But it's not within what we would consider to be our acceptable data range. And that's a modified box and whisker plot. Okay, and it's a diagram that's in the expectations that we're supposed to be able to do. Again, Microsoft Excel does box and whisker plots, not modified box and whisker plots. So keep that idea in mind. But it does plot all of the points, acceptable or not, that are outside of the interquartile range. So that's something that you'll see if you try Microsoft Excel. The last thing we're going to talk about is a percentile. So quartiles divide things into 25, right? 0 to 20, 25, 25 to 50, 50 to 70, 75, 75 to 100, okay? So quartiles divide things in 4, okay? Which are kind of like 25%, 50%, 75%. Q1 is 25%, Q2 is 50%, and Q3 is 75%, okay? But we also have percentiles. And percentiles are actually used a little more often than you would think. First place I saw it used in my everyday life, outside of school, of course, was when we were looking at baby weights and heights when my children were born. Okay, and they were within a certain percentile. What a percentile means is, if you're saying the 90th percentile, that means that you are up at the top of 90% of the people. That means that if you're at the 90th percentile, it means 90% of the people have your measurement or less. Okay, if you're in the 50th percentile, which is the median, that means that 50% of the people have your value or that value or less. Okay, so let's say we do a percentile for, I don't know, a mark of a test out of 20. Okay, and let's say the 90th percentile is 15. That means that 90% of the class got 15 out of 20 or less, which means they didn't do very well on the test. Okay, and so that's what a percentile is. It just looks at the measurement as comparison. It's like a proportion of the whole. Okay, and there are a couple of formulas that we use for percentiles. I'm not going to really go over these too much, okay, because there's other ways to calculate percentiles that are a bit more accurate if you're normally distributed, but this one works for all data sets appropriately, which tend to normally distribute anyway for most of these measurements, but that's neither here nor there. Okay, so first of all, to calculate the percentile, so if you have a mark, a value, and you know it's the, I don't know, let's say there's 75 values, and it's the 60th value. Okay, to calculate what percentile the 60th out of 75 is, you don't go 60 out of 75. Okay, what you do is you use this formula. Okay, so to calculate the percentile of a particular datum, particular value, QI, any particular score, measurement, because it is per measurement, kind of like a standard deviation is, we use the following formula. Okay, and we take 100. Okay, and we take L, which is the number of values below it. Okay, so let's say we're taking the 60th value. There's 59 values below it. E is the number of values equal to it. So you could have that value repetitive. Okay, so whatever that is. So let's say that, I don't know, my child's baby weight is 9 pounds. Okay, and then we look at all the baby weights in that hospital, okay, for the last year, and there's like, I don't know, like 100 kids that are 9 pounds or less. Okay, then I would put 100 for the kids who are lower. Let's say there's 2 kids who are 9 pounds. I would put a 2 in there, so I would put 100, and then I would put 2, and then the 0.5, I'd have to, of course, multiply that by, n would be the number of babies that were born. So let's say, I don't know, there's 120 babies. Then you would go ahead and figure out what that percentile score would be. Okay, and it's a simple calculation that you would do, and I'll show you an example, of course. Okay, all right. So, sorry, let me grab my piece of paper. Now, to calculate the percentile rank, okay, we do the basic idea. So let's say you wanted to find out, okay, who's in the 90th percentile or who's in the 95th percentile? What score? How heavy is a baby in the 95th percentile? So what you do is you put the 95 in there for your percentile. That's P. Your N, again, is the number of data values there were. I think we said there were 120 babies. And then you went from there. Okay, so it's basically 95% of 120 plus 1. It's a very easy to do. And then that would tell you, okay, well, that's the weight of a baby who was in the 95th percentile, or 95% of the babies were that weight or less. And that's really what it's all about. So here's the data set. Okay, I can't remember what this was. This was taken from from your textbook. Okay, what I've done is, again, you have to rank the data values. You have to put them from smallest to biggest. Okay, so 10 is the lowest, and they go down, and then start back up here. So they kind of go like that. Okay, and we want to find the value corresponding to the 60th percentile. Okay, the 60th percentile. All right, so this is when we know the percentile. So we know the P, the 60th, and we want to find out what score is the 60th percentile, where 60% are below it, and then of course 40% are above it. Okay, so if we look at the 60th percentile, the data set has 50 values. Okay, so there's 50 values in total. That's my 50 there. So 50 plus 1. Okay, 51. And then I'm looking for the 60th percentile, so 60 over 100. So 60 times 51, 3,060, I think. 51 times 60, yeah, 3,060. And I divide it by 100 and I get 30.6. Okay, so that means that a score of 30.6 is the 60th percentile. That means that anything below 30.6 is 60% of the people got that value or below. And then, of course, anything above the 30.6, a score, is better than that. So you're outside of the 60th percentile. Okay, and that's a score of 30.6. Okay, so the 60th percentile is located between the 30th and 31st datum. Sorry, not a score, sorry. That's the rank, percentile rank. So that means that, notice how it's a 30.6. That means it's between the 30th and the 31st. Okay? Which does make sense because we have 50 data points. And if we have 50 data points, 60% of 50 is 30. Right? So, but anyway, this formula kind of does it a little bit more telltale for you. So between the 30th and the 31st value. So that would be, this is 10 out of 50, so that would be 20%, 40%, 60%, which would be right here and right here. So between the 30th and the 31st, okay, so between 63 and 66, which of course would be a 64.5. So that would be the actual value for that. I think I made a boo-boo in my calculation here. No big deal. Okay, that's the idea. Okay, between the 30th and the 31st value. Okay, which is of course 61.5. Okay, sorry, 64.5. All right, I'll change that. All right, so now if we wanted to figure out what our percentile is, okay, we have a score, we have a measurement, and we want to figure out the percentile that it is, P, okay, then what we do is we plug it into the formula, but we have to count the number of values that are above or below it, so we of course have to pick a particular value. In this case, 80, that's my x sub I. Okay, so I find 80, there it is there. It doesn't have to be in here, but you could find where 80 is roughly located. Okay, now in this case there's only one that are exactly 80. If it was like 80, 80, 80, then there would be 3 of them. So that is my E. Okay, so my E is 1. Then I would say, okay, well, how many values are below it? 1, 2, 3, 4, 5, 6, 7, plus 10, 20, 30, 37 below it. So that would be my L, my 37, that are lower than that. Okay, and I take my E and my 37. I divide it by my total. My total, remember, is 50. Okay, and then from there I got 37 plus 0.5, or 37.5 divided by 50. Okay, and it ends up being 75. Okay, so that means that this particular score of 80 is the 75th percentile. Okay, and it tells you the percentile as the final score. So the 75th, 80 is the 75th percentile. That means that this down is 75%. Okay, or that value or below, and this up here is 25% of it. So the first quarter and the bottom quarter, top quarter and the bottom 3 quarters. Okay, so give these ones a try. Okay, but that's how you do percentiles as well. So there you have it. Okay, so have fun with that.